Right, this recording is to help you with lesson 5.04, the sum and difference formulas. Alright, so basically we use the sum and difference formulas if we're given an angle or a measure that is not on our unit circle. Alright, if we're given a measure that's not on our unit circle, we ask ourselves, is there any way I can rewrite it so that I am using two values from my unit circle, that when I either add them together, I get the value given, or when I subtract them, I get the value I'm given. So for example, 11 pi over 12, that is not originally on our unit circle. But 3 pi over 4 and pi over 6, they are. So if I add them together, I actually get 11 pi over 12 once I have my common denominator there. So what I can do is I can use the sine, cosine, and tangent formulas to figure out what these actually equal. So I can do sine of 3 pi over 4 cosine pi over 6 plus sine pi over 6 cosine 3 pi over 4. And all of these formulas are given to you in the online lesson. Okay? And then using my unit circle, I can substitute these values in. Right? And then once I actually go ahead and multiply them out, I get the square root of 6 over 4 plus the square root of 2 over 4. And I'm generally just going to write them as like this, square root of 6 plus square root of 2 all over 4. I generally don't tend to factor anything out. I think it's more complicated that way. So for sine, I would leave my answer like this. Using the cosine formula, I would have, let's see, negative square root 6 over 4 minus square root 2 over 4. So I would leave my answer as negative square root 6 minus square root 2 all over 4. And then tangent's always a little bit tricky because it actually is dealing with a fraction in the equation itself. I get negative 1 plus square root 3 over 3, 1 plus square root 3 over 3. And once we actually get common denominators there, and I'll do this one real quick to refresh your memory on how we can do so. I'm going to rewrite negative 1 as 3 over 3. And in the denominator, I'd have very similar to the same thing, only it's a positive 1 to begin with here. And since they all end with 3s, or all the denominators are 3, those drop out. So really I'm left with negative 3 plus square root 3, all over 3 plus square root 3. And we can't have that that radical in the denominator, so I need to multiply by its conjugate. So after I multiply by its conjugate, I end up with, let's see, in the numerator I get negative 9 minus 3, because the middle terms drop out. And in the denominator, did I get that? Maybe I don't. Negative 9, positive, oh, nope, I get a positive 6 square root 3. I FOILed wrong in the numerator. Alright, once you FOIL this out, hopefully, you'll get the same thing here. Nine minus 3. There we go. I'll get it eventually, right? So negative 12 plus 6 square root 3 all over 6. And that, I'm running out of room, so I'll jump back over here. You can divide everything by 6, and when you do so, you get negative 2 plus square root 3. So tangent always takes a little bit more work because you do have that fraction involved there. Right, we can also work backwards to try to figure out what sign will be. So here we're actually given the formula. We need to decide which trig function it's talking about. Looking at the formula, because it uses sine, cosine, cosine, sine, I know that it's talking about sine of something. And it's comparing the 230 degrees and the 30 degrees. Now because we are subtracting here, and it is the sine formula, we need to subtract those degrees. So really, what are we talking about? We are talking about sine of 200 degrees. So that is what we were looking for. So we can also work it backwards to see what degree we were actually looking for in the first place. Alright, you may see problems where you have to find missing information. So for example, if I know that sine of u is 5/13 in the first quadrant, okay, so I'm going to draw a triangle in my first quadrant. It's a 5, 12, 13, okay, so if sine of u is 5/13, I know cosine of u is 12/13. Okay. And then for my second piece of information, if I know that cosine of v in the second quadrant is -3/5, I can draw my right triangle out. I know the missing side is 4, so sine of v, because I'm going to need this, sine of v, let's see, opposite over hypotenuse, so 4/5. Okay. Once we have that information, I can then find what sine of u plus v is. So using that formula, we know we get sine of u cosine v plus cosine u sine v. And now we just plug in the information. Sine u was 5/13. Cosine v was -3/5. Cosine u we found to be 12/13. And sine v we found to be 4/5. So multiplying those together, you get a -15/65 plus 48/65. That gives us a positive 33/65 for our final answer there. Alright, next we need to verify the identity. So we are just going to simply use our sum of angles formulas and the difference of angle formulas here. Writing this all out, I get cosine x cosine y plus sine y cosine x. And then writing the second one out, I get sine y cosine y minus sine y cosine x here. And then we're going to combine like terms. So sine x cosine y plus sine x cosine y is 2 sine x cosine y. And the other ones are actually going to cancel each other out. So using that and then combining like terms, we were able to verify the identity. Last one is very similar to this. Let's just expand those. So we get the following using our formulas. Let's combine like terms. So we get 2 sine x cosine pi/3. And the other ones cancel out. Well, we know that cosine of pi/3 is actually on our unit circle, and that's equal to 1/2. So let's multiply 2 times 1/2 here, and that's just equal to 1. So really where does sine x equal 1? Sine x equals 1 at one spot only, and that is at pi/2.